Hello, ladies and gentlemen. Welcome back. We are on Unit 6.3. In this unit, we're going to talk about rational exponents and roots. Now, we're going to begin by reviewing some perfect squares, then looking at what the square root looks like, and then we'll talk about those rational exponents, because we're going to be using that in this lesson and the next one. All right, so let's review our perfect squares really quick. All right, 1 squared is 1. 2 squared is 4. 3 squared is, remember that's 3 times 3, it's 9. 4 squared is 16. 5 squared is 25, and so on, dot, dot, dot. All right. Now, you know that the square root looks like this, ladies and gentlemen, right? Okay, that's the square root symbol. And the square root is just undoing a square, so the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on. All right, now let's look at the rational exponents. Oftentimes when we're solving equations, we're going to have exponents that are fractions. Okay, rational exponents means fractions. Okay, exponents that are fractions. So the rational exponent in this case is going to be like taking the square root. Okay, so here we go. I'm going to go ahead, and you have to use parentheses, folks. So I'm going to put this 1 in parentheses, and I am going to put to the half power. The half power is the square root. Because if you recall, ladies and gentlemen, there's a 2. You don't see it when it's a square root, but there is a, if we did put a number in that little spot right there, it would be a 2. Okay, but we don't write the 2 there when it's a square root. Okay, when there's nothing there, we just assume it's the square root. You'll see details when we get to the next one. So the half power of 1 is 1. Okay, now if I take the 4 to the half power, okay, that's going to be 2. Now, ladies and gentlemen, okay, let me pull up this calculator. When I do this, okay, I'm going to go 4 like this. And it's a good idea to practice this. Pause and practice it a few times on your calculator. Okay, I'm going to hit that exponent button. Okay, now with these fancy calculators, it's not quite as important that we put the exponent in fraction. If we had an older calculator, okay, if we had an older calculator, like if you have an older handheld one, you would need to make sure you put that in fractions. But since the calculator is already making that, when it puts that little exponent up there, okay, it's not necessary to use those parentheses. Okay, so just be aware of that. So if you have an older calculator and you're actually using the older calculator, not the one on your Chromebook, you need to make sure you put parentheses around that exponent. All right, so you can see 4 to the half power is 2. And again, 4 to the half power is the same as the square root of 4. Okay? All right, so let's keep going. So that means, ladies and gentlemen, 9 to the half power is going to be 3. 16 to the half power is going to be 4. And 25 to the half power is going to be 5. Okay? All right, let's do a few more here. Let's go to perfect cubes, ladies and gentlemen. All right, like 1 cubed. 1 cubed is 1. Okay, 2 cubed. Now remember, 2 cubed means 2 times 2 times 2, which is 8. 3 cubed, that's 27. Okay, 4 cubed. Now remember, you have your handy dandy calculator, ladies and gentlemen. So if you don't know what 4 cubed is, you know, you could just type it in and go, oh, okay, 4 cubed is 64. All right, 64. And then 5 cubed, okay, I know that one. That's 125. All right, if you don't know it, use your calculator. Now, what does the cubic root look like? Okay, so the cubic root, ladies and gentlemen, that's where we put that 3 right there in that corner. Okay, it's small and put right there in the corner. All right, so all of these are cubic roots. I usually like writing the number first and then drawing the root symbol. Okay, but it's up to you how you want to do that. So that's the cubic root. And so again, the cubic root of 1 is 1. The cubic root of 8 is 2. The cubic root of 27 is 3. The cubic root of 64 is 4. And the cubic root of 125 is 5. Now, there is a cubic root button, but I'm not going to show it to you because it's not all that convenient. Okay, you got to push a few buttons to get there. So, and the primary purpose of this is being able to use the rational exponent. So what is that going to look like, folks? So that's going to be 1 to the 1/3 power. The 1/3 power is the same as the cubic root. Okay, 8 to the 1/3 power. Okay, just to show you real quick with the calculator. Again, if I go 8 to the 1/3 power, again, since we've got the newer calculators, we don't need to worry about those parentheses. See, it's 2. 8 to the 1/3 power is 2. All right, and so on. 27 to the 1/3 power is 3. 64 to the 1/3 power is 4, and the 125 to the 1/3 power is 5. And we're going to need to know these things because we're going to be solving some equations with all of this. All right, let's do just one more set here really quick. All right, and that's to the 4th power. So here we go. 1 to the 4th power is 1. Okay, 2 to the 4th power, remember that's 2 times 2 times 2 times 2. Well, that would be 16. 3 to the 4th power, well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3, that must be 81. Okay, 4 to the 4th power, okay, 4 to the 4th power is 256. And 5 to the 4th power is 625. All right, what does the 4th root look like? So we would put a little 4 right there with the root symbol. Okay, and so on. So that's what the 4th root would look like. Again, there is a way to do the root on your calculator, but it is not convenient. Okay, there's a better option to use the rational exponents. All right, so the 4th root of 1 is 1, 4th root of 16 is 2, and so on. All right, now what's the rational exponent look like on that? Well, ladies and gentlemen, that would be to the 1/4 power. All right, so instead of the 4th root, we use to the 1/4 power. That's going to give us, just going to show it to you quick, that's going to give us what we want. Okay, 16 to the 1/4 power is 2. All right, so I'm just going to go ahead and fill this in the rest of the way down. Okay, now let's get into what we really want to do with this. We want to solve some equations. Now, we're going to solve these equations using rational exponents. And you'll notice I put over here, we're going to find only the real solutions. Okay, there are things that we don't get into in this course that are called imaginary solutions. If you take the other advanced algebra, we definitely get into those because you need to know those before you'd move on to like pre-calculus and other higher level classes. Okay, but we're not going to get into the imaginary. So we're only finding the real solutions. And the reason I say that, folks, is because technically this problem, this first problem, technically has 4 solutions. Okay? Technically, it has 4 solutions. But we are only going to be finding the real solutions. All right? Because there are some imaginary. All right? So that's what it technically has. But we will find only, that's an L, the real solutions. Okay, we will find only the real solutions. Now, since this is even exponent, okay, two real solutions. So that means, ladies and gentlemen, that we got to come up with two answers for this one. All right, here we go. So first thing we're going to do, ladies and gentlemen, is we're going to divide by 3 because we want to get that x to the 4th power by itself. Okay, I'm just going to use my handheld calculator here to help me out so I don't have to flip back and forth. So I'm going to take 3888 and divide it by 3, and I'm going to get 1,296. All right, now, ladies and gentlemen, what I'm going to do is to get rid of that exponent of 4, I am going to do the 1/4 power. So this 4 and the 1/4, they're going to cancel each other out. And that's going to equal positive, negative, okay, two real solutions here because it's an even exponent. And I'm going to take 12,000. Okay, I'll do this on this calculator. So we'll take the 1,296 to the 1/4 power. All right, so positive, -6, ladies and gentlemen. Those are my two answers. Okay, again, I just typed that in using the 1/4 power to get rid of that exponent of 4. Okay, now just to prove that both the positive and negative work, I'll do it with this problem, but then I'm going to skip the check step. I'm going to go ahead and go 3 times the 6, positive 6, to the 4th power, ladies and gentlemen, and I'm going to get 3,888. If I take 3 times the -6, which is the other answer, to the 4th power, I'm going to get 3,888. So even exponent, we're going to have two real solutions, okay? But again, technically there are 4 solutions, but that means the other 2 are imaginary. All right, let's keep going here, folks. All right, on this one, okay, so I want you to imagine that the parentheses is like a room and the 3 is like a lock on the door, okay? So you cannot get, the 7 cannot go anywhere yet until you take the lock off the door. Okay, you can't get out of the room unless the door is unlocked. Now, to unlock this room, ladies and gentlemen, we're going to have to get rid of that exponent of 3. So that means we're going to need to use 1/3 for the exponent on both sides. Okay, I failed to do it on that last problem, but remember, what you do to one side, you do to the other. Okay, so these are going to cancel out on the left side. And we're going to get x plus 7 equals, all right, now we're going to take the 343 to the 1/3 power. 343 to the 1/3 power. And we get 7. Now, ladies and gentlemen, forgot to mention this. If it's an odd exponent, we're going to have one real solution. So only one answer, one real solution. Okay, technically this one has 3 solutions, but one of them is real. All right. Okay, so what did that equal again? 7. Well, there's only one step left, ladies and gentlemen. I am going to take away 7. And so I end up with x equals 0. That's our answer. That's the only answer. Okay? You can't, well, this one, you can't have a positive and negative 0, but again, odd exponent, one real solution. Okay, watch out for those details. All right, let's do a couple more. All right, so in this one, we're going to go ahead and notice there's no parentheses here. So here we're going to go ahead and get rid of the 4 first. So we're going to take away 4. So then we've got 5x to the 6th equals 3,645. Okay, now we get rid of the 5. Divide both sides by 5. And now x to the 6th equals, okay, I'm just going to use my handheld calculator here, 3645 divided by 5. 3645 divided by 5. Okay, there we go. 729. Okay, now folks, notice that this is an even. Technically, it has 6 solutions. 1, 2, 3, 4, 5, 6. But they're not all real solutions. Okay, since it's even, we're going to find 2 real solutions when we go through with this. Okay, 2 real solutions is what we're looking for. Now, to get rid of that, remember, we're going to go ahead and use the fraction 1/6. Okay, so the 6th and the 1/6, they neutralize each other. And we have x equals positive negative. Don't forget, there's 2 answers, positive, negative. And I'll just use this calculator. So 729 to the 1/6 power. 729 to the 1/6 power. Whoops, forgot the fraction. Oh, look at that, beautiful. It's a work of art. Positive, -3. And if I check the answer, +3 and -3, it would work. All right, let's keep going here. We got one more. All right, here we go. Okay, hopefully that was enough time on that one. Remember, you have the power of pause and rewind. All right, so on this one, you'll notice that there are parentheses. So I can't do anything with the -4 yet because there's an exponent keeping it there. But first, we got to get rid of everything else around it. So we start by getting rid of the +2. So we're going to take away 2, folks. And notice that the exponent is even, so that means we're going to have 2 real solutions on this one. 2 real solutions. Okay. All right, so let's see. Now we have 3 times x minus 4 squared equals 75. Okay, now, the next thing we get rid of is the 3. Again, we can't get rid of the -4 yet because it's being locked by that exponent. It can't go anywhere until we get rid of the exponent. But first, we get rid of everything else around it. So now we're going to divide by 3. So now we have parentheses x minus 4 squared equals 25. Okay, now, to get rid of the 2, we're going to do to the half power. Again, this 2 and the half neutralize each other on that left side, and we're left with x minus 4 equals positive negative. Okay, well, you should know 25 to the half power, folks. 25 to the half power is going to be 5. Now, we have positive -5. Okay, ladies and gentlemen, we're going to have 2 separate, distinct answers here. Okay, because we still have one more step. We're going to add 4 to both sides. Now, when I write this out, I'm going to write x equals 4 plus 5, because one of them is a +5, which is 9, and the other one is 4 minus 5, which equals -1. Okay, so be careful on these. Don't go, oh, 9 and -9. No, 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 no. Okay, you got to separate them, the 4 plus the 5 and the 4 minus the 5, and get 2 distinct answers. All right. If you didn't get any of that, go back and re-watch part of this again, and we'll practice more of this in class. All right, see you soon, ladies and gentlemen.